motor, and the motor is connected to a gearbox, and that will increase the speed with about factor 3, and that will operate the alternator. Inside the alternator is a rotating metal disc with a diameter of 1.6 meter. And it has 488 cutouts in its periphery. And due to those cutouts, there will be a magnetic flux inside the alternator that will vary with a frequency of 17,200 hertz or 17.2 kilohertz. And that is our transmission frequency. And now I will show you the auxiliary machinery. Here you can see a number of generators, fans, water pumps, and more. This is what we call the auxiliary equipment. We need 500 volt DC to adjust the speed of the drive motor. And this is really important because the drive motor speed is directly affecting the frequency of the alternator and elegant, and it's still functional. We also have 2 water pumps for the cooling system, and we have 3 large water liquid rheostats, and we will talk more about those when we start up the machine. Here are 2 cooling fans. The cooling fans are used to create a very heavy airflow to cool those large contactors that control the speed of the motor. And we will go and have a look at those contactors. Here at the top we see a very small relay. It's about 1 watt of power, and that relay is directly controlled by the Morse key. The signal is then amplified into a larger contactor, and then furthermore amplified into an even larger contactor. This one here is is air-cooled, and this one is then operating these 3 large contactors that are used to control the speed of the motor. And they also air-cooled. You can see the air inlet pipe here. So let me now show you the operator panel. There are a lot of levers, switches, wheels, gauges, etc. to look at and to operate. On the left-hand side of the operating panel, we have the 2 large levers where we have the main power and we have the power to the drive motor. We can also start the auxiliary 500 volt generator, 125 volt generator. In the middle here, in the center, we have a very intricate system called the automatic speed control system that will help the motor to maintain its correct speed and also correct frequency. On the right-hand side of the operator panel, we have a number of buttons, levers, etc., where we can fine-tune the frequency. We have a speedometer to see the speed of the motor. We have a voltage meter to see the voltage to the drive motor. And I have a small Morse key where I can operate the transmitter. Okay, so I think now it's time for us to prepare for the startup of this transmitter. We have done some checks before. We have checked that there is oil in all bearings because there are no ball bearings on this transmitter anywhere at all. So it's all friction bearings with a small oil container and a small slip ring that will lubricate the bearing. We have to go and turn on the power. The power supply here is from the 50 kilovolt main grid we have a small transmitter house about 150 meters away from here. And in that house is a switch that I can operate remotely from inside here. Then the 50 kilovolt will be transformed into 2300 volts and converted from 3-phase to 2-phase. Because this machine was designed at the time in America when 2-phase power supply was the common system. So let me go down and do that maneuver now. Okay, so now we have connected the machine to 2300 volts. I will go back to the operating panel and I will ask my operator to go down to the emergency switch. And I will make visual contact with him. And we have no alarm. That's fine. The alarm button was off. We can live with that. The alarm now is telling us that we need to do some more work. The machine needs water cooling and it needs oil pressure for its bearings to the alternator. But let's begin with the water cooling. We have 2 cooling water pumps, number 1 and number 2. We will be using pump number 2 today. And why is there 2? Because of redundancy. If one would break, we can always run the other one so that the transmitter can continue to function. And Anders now is starting by opening up a water valve to fill up the housing of this pump with fresh water and remove all the air. And that's done, and now Anders will go to the starter. And it's P2, Anders will be starting. And now we can see that the pump is running, and we can see some water is leaking, which is fine. It's a 100-year-old cooling water pump, and he now begins to open the valve to the circulation system, and this is probably the heaviest job for him today. It's about 25 tons and you need to add a lot of force. And we can see on the gauge on the wall that now we have 2 bar pressure. That's fine. And I have closed the valve on this here. So now we look at one of the liquid rheostats. The liquid rheostat we are looking at here is called the compensation rheostat, and it's used to compensate the resistance inside the motor rotor when we are pushing down the Morse key. And the next rheostat is called the start rheostat, and is used to control the speed of the motor or the resistance inside the rotor when the key is not pressed down. There is a small, the containers contain 400 liters of water together with sodium carbonate. I will open here. And there is a small circulation pump in each tank, which we now will start manually. And this is done with a small wooden piece of wood. And Anders is using protective gloves because there is 440 volts where he's pushing. And now we can see on the screen and we can hear that the water is starting to flow inside the tanks. So the next step now for Anders is to turn back the alarm bell. And now it's telling us that we have no oil pressure to the bearings. And we have an auxiliary oil pump that Anders now will start. And the alarm goes out. And now it's time to start the main drive motor. And Anders will go down to the emergency stop. Okay, I say Anders. And now we can see that the motor is starting to rotate. We can also see that the amperage to the motor is about 150 amps about. The voltage is about 1,300 volts. So there's a lot of power now going to the drive motor. And it's slowly increasing in speed. And as the motor now is increasing, we can also see that the amp is going down. We are at 140 now. Speed so far is 250 RPMs. Our target speed is 711.3 RPM. That correlates to 17.2 kilohertz. So we're looking at the amperage gauge and we are waiting for an alarm signal. And the alarm signal will indicate that now the oil pressure is getting too high. Inside the gearbox is another oil pump. And when the speed is coming up to a sufficient RPM, we can turn off the auxiliary oil pump. We can see that the amperage now is getting close to 100 amps and is continuing down. We will be waiting until we reach about 80 amps before we can continue. We are at 90. And there we go. We have the alarm for high oil pressure, and now Anders can turn off the auxiliary oil pump. And we are getting close to 80 amps in about a couple of seconds. All right, Anders. He's turning on the 500 volt and the 125, 250 volt generator, and now he will activate the field current to the 500 volt generator, and immediately we add another 1000 volts to the drive motor, and now you can hear, and the people in the room here can feel how the speed is increasing. So we are already now at 550 or almost 600 RPMs. And now Anders is maneuvering the two liquid rheostats with push buttons from the operator panel. And he increases the water level inside of them so that the tubes that you can see on the picture now are getting into contact with the water and thereby lowering the resistance, giving the motor more thrust. So now Anders is magnetizing the alternator. And now we have a magnetic flux inside. The frequency is still very low, but as the speed increases, we can see that the frequency will also get closer and closer to 17,200. So now Anders is looking very closely at the voltage meter to get the voltage meter to read 2000 volts. Jag tycker vi är bra där. Okay, so now Anders has made a rough tuning. We have about 2000 volts, so just below, which is optimal. Frequency is now reading 17,191. We are still not connected to the antenna though. Before we can move on, Anders has to go down and turn on the cooling fan. So and the cooling fan makes a lot of noise. So as soon as the cooling fan is turned on, it is literally impossible to communicate in this room without screaming very loud. So frequency is pretty stable. We're at 17,190, which is fine for now. Next step would be for Anders to connect the alternator to the antenna. And he's doing that by a motorized night switch, which you can see on the screen now. And there it is, trycking knappen. So. And now we can do the first test to see how the machine is reacting. And we can see on the gauge to the antenna that yes, there is some power going out to the antenna. Lite högre, ja. And now Anders is pushing the key, and at the same time he's monitoring the voltage. And we're doing quite okay. And he's also looking at the antenna current. And it's very hard to read as the meter is logarithmic, but we believe we have fine power. So maybe we should put on the punch strip recorder to warm up the antenna, because we have rain here today. frequency of the antenna, and the resonance frequency has to match the alternator, or we will not have a good strong signal out in the air. So let's leave it on like now for a couple of minutes, and we will go. I will take the cameraman with me, and we will go outside. So we have a little bit of rain in Grimeton today, about 50 kilometers south of us. There are tremendous thunderstorms right now, so we are very happy not to have that weather here. And behind me you can see a cooling pond with a set of fountains that will actually spray the cooling water up into the air to give it some extra cooling. When back in the days when the machine was run 24 hours a day, this was necessary, especially in the summertime, to keep the temperatures down. Today this is more for show rather than cooling, as we are only running the machine an hour or so at a time. And then we have those fantastic Alexanderson multiple tuned antennas, 6 antenna towers that are working together. Alexanderson made this antenna to make sure that we can increase the efficiency compared to the second best antenna at the time, which was made by Marconi. So Marconi's antenna had an efficiency of 2%. Alexanderson's antenna had an efficiency of about 14%. Today we believe we have an efficiency of between 10 and 12% because of age. The distance between the first tower and the last tower is 2,300 meters. The height of each tower is 127 meters, and they were for many, many decades the tallest buildings in Sweden. And if we turn a little bit to the right, we can see a small building being renovated. That building is called the Ice Melting House. It's being restored now to its original design and look. Inside is a huge transformer that back in the days could create enough power to the wires going up into the antenna and melt ice in the middle of the winter to prevent the wires from breaking. And there you can also see one of the large tuning coils. And this tuning coil is for tower number 1, and each tower has its own tuning coil. So we have 6 coils like that out on the field. Each tuning coil is then connected to an underground copper network. The copper network is 500 meters wide and 2,500 meters long. About 200 kilometers of copper wire is dug down into the ground here. And each coil is connected on 14 different points, not to have too much stress to an individual point. So I think we'll go back in again. between the inner and outer, there is a third coil that is supplied with 250 volt DC when the Morse key is up, which will prevent the induction from the inner to the outer with about 90%. So 90% of the power would stay here, but 10% is still leaking out into the antenna, even though the key is not pushed down. But at the bottom there are two transductors, or adjustable inductors, and they are a part of the tuning circuit of the antenna. So when the key is up, the antenna is tuned to the wrong frequency. So those 10% will almost disappear. But if you are nearby and you have a very sensitive receiver, you can still hear that carrier wave from SAQ. However, as soon as the key is pushed down, the 250 volt is blocked to the transformers and to the transductors, and we have a perfect signal going out to the antenna. And there is a small tuning coil that we can maneuver from the operator panel to make the last fine-tuning of the antenna. Very elegant, very robust, no moving parts, and it can maneuver 200 kilowatts. Jag tycker vi ligger där vi ligger, eller ska vi ändra? Men det gör vi så som vi gjorde sist, en dutt på varje. Ja, ja. Ge en kort, en halv sekund på varje. Så ja. So we are a little bit low on frequency. The meter now reads 17183. So Anders is making some small adjustments here, and now we are at 17,200. So I think we are fine. So we can leave it like that. Transmitter hall here to monitor our own signal from the Netherlands. So this is the receiver in the Netherlands. We can see that SAQ is visible here. In the days when this transmitter was operational, there was never a person sending any messages from here. This station was remotely controlled from Gothenburg over the phone line. So in Gothenburg there was an America room, and they had somewhat similar transmitter as we have here today. And if you had a message that was going to be sent to someone in America, this was punched into a strip similar to this one and put into a transmitter, and then Gothenburg would call here to Grimeton and say that now we have messages to send, so could you please start up the transmitter? And when the transmitter was up and running, they started the reader in Gothenburg, and the transmitter started to send messages. the same as SMS or texting on your phone, a little bit quicker. So that was the total communication capacity that Sweden had in the 1920s with America. So one message was really expensive. You would have to pay 1 krona or 10 euro cents for each word. And 1 krona was your wage for 1 hour's work. So you made your messages very short, and you only sent messages when something important happened. Someone got married, someone died, or so. Not just to say, hello, how are you? That was too expensive. So we're getting very close to 11 o'clock. It's about 2 minutes left. And our telegraphist, Kai, is making himself ready. Okay, so now we have 1 minute left. I will turn off the punch strip recorder, and Kai will make himself ready. Very good, Kai. Thank you very much, Kai. That was our message to the world this year. We are talking about that the radio station was getting completed and that the 2 alternators was ready inside here, each one with the 3 important developments: a rotating alternator, a magnetic amplifier, and a multiple tuned antenna. And with transmissions starting across the Atlantic Oceans in December, we will begin to celebrate in December and continue until July 2nd. So see grimeton.org for details. So by that, we are now ready to turn off the transmitter, and I will ask Anders to begin that procedure. And the first thing he will be doing is to switch off the field current to both the 500-volt generator and to the Alexanderson alternator. And I will go down and I will stop the main drive motor. So now there is no power to the drive motor. It still rotates, and it will so for about 9 minutes due to its heavy weight. The disc alone weighs about 1,500 kilos, so there's a lot of momentum. And Anders is now returning each liquid rheostat to its bottom position, which is key for our next transmission this afternoon, or it will not start. And now Anders will turn off the cooling fan. And now it is getting almost quiet again in transmitter hall. Yes, it's a very big difference. And now we get an alarm for low oil pressure. I will assist Anders. So we'll turn on the auxiliary oil pump. So the Alexander Association has about 700 members. Each member is paying a member fee of 125 kroner a year, which is about 12 euros. And our mission is to maintain this beautiful machine, keep it in operational condition, to hold courses, and to produce literature and other type of information to our members, and preserve this for the future. So your membership is very valuable. Easiest way to become a member is to go to our website, which is alexander.n.se, N as in Nicholas. So alexander.n.se, and apply for membership and become one of the supporters to preserve this beautiful transmitter, unique transmitter in operational condition. So now it's time to say goodbye to all you viewers. We have had 700-800 viewers about, which is fantastic, together with a couple of, at least 100 people, 150 people inside the transmitter hall. So from Grimeton Radio Station, Sweden, we would like to say thank you for watching. Hope you will all become members now in our society, and stay tuned for the transmission that will come this afternoon. We hope to see you again there again. So thank you very much. Bye-bye.